Have you ever stopped to think about why traditional houses around the world look so completely different from one another, yet a modern office building looks exactly the same whether it's in London, Dubai, or Tokyo? Seriously, it's wild when you think about it. Today on The Explainer, we're unpacking the really deep relationship between a building's fundamental design and its climate. We're going to figure out how a structure's physical form and its outer skin completely dictate its true efficiency.
Here's our roadmap for today. We'll start off with designing greater efficiency, then move right into form, skin, and climate before diving into building physics fundamentals. And finally, we'll look at vernacular architecture in two extremes, the jungle and the Arctic.
All right, let's jump right into Section 1, Designing Greater Efficiency and the Broad Scope of Sustainable Design.
So, when we talk about global sustainable design today, we're usually talking about this massive scale of engineering. We're constantly analyzing resource metrics, complex HVAC systems, huge solar arrays, the carbon intensity of materials, and, the green mortgages just to pay for it all. But here's the secret. While those high-tech systems are absolutely vital, true efficiency doesn't actually start with technology. It starts much earlier.
Just take a look at the modern engineering approach. We build these absolute marvels of glass and steel, drop them into literally any environment on Earth, and then use massive amounts of energy to heat or cool them. Honestly, it's entirely backward. To be truly efficient, we have to look past the shiny glass box and look at the geographic fundamentals. We absolutely have to look at the climate. Which brings us to Part 2, Form, Skin, and Climate, the core framework. The main idea here is that before you even think about slapping complex technology onto a structure, a building's basic shape, its form, and its exterior, its skin, must respond directly to where it sits. We call this bioclimatic design. You simply cannot build effectively if you just ignore the sun, wind, and temperature of your specific GPS coordinate. It just doesn't work.
Consider this for a second. A standard 5-story office building in New Delhi. It's about 4,000 square meters, wrapped in 60% glass, with its longest facade facing southeast. Now, New Delhi has a climate that regularly pushes way past 40 degrees Celsius. So we have to ask ourselves, does a giant glass box in the intense Indian sun make any passive sense? Or is it really just a giant greenhouse that needs a massive energy-sucking air conditioning system just to keep the people inside from passing out? It's a prime example of why we have to master the climate way before we master the technology.
Let's move on to Section 3, Building Physics Fundamentals, Understanding the Elements.
Designing for a specific climate basically means mastering building physics, and specifically how we manage heat transfer. Whether we're desperately trying to keep heat out in the dead of summer or trap it inside during a freezing winter, physics is this invisible hand dictating our comfort. And honestly, the best way to master this is to look backward.
To manage that heat transfer effectively, we really have to respect radiation, which is the transmission of heat waves directly through space. Just picture the harsh sun beating down on a roof. Our buildings are locked in this constant physical battle to either deflect that radiant energy away or capture it like a sponge.
That takes us to Section 4, Vernacular Architecture in the Jungle, Lessons from the Canopy.
Now, the Korowai are a tribal community in Indonesia who were actually completely isolated from the rest of the world until around 1970. For generations, they've lived in an incredibly dense, sweltering jungle. But here's the catch. They don't build their houses on the ground. They build them at the very tops of towering trees. So why do that?
Well, by elevating the building's physical form high up into the canopy, they brilliantly manage the extremes of both heat and humidity. Down on the jungle floor, the air is totally stagnant, wet, and oppressive. But by raising the form, they actually catch the prevailing breezes. Plus, they use a highly breathable, open skin made of local materials to let that breeze flow right through the house. It is a literal masterclass in using form and skin to naturally defeat humidity.
Next up, Section 5, Vernacular Architecture in the Arctic, Surviving the Freeze.
So let's flip to the complete opposite extreme. How do indigenous communities in the freezing polar regions survive using the very element that makes their environment so deadly? Think about it. How do you build with the cold to defeat the cold?
The answer, of course, is the igloo. They literally build homes made entirely of compacted snow. But why on earth does a house made of ice keep you warm? Well, it goes right back to radiation. That thick, dense layer of snow acts as an incredibly efficient insulating skin. It completely stops the heat generated by human bodies from transferring out into the freezing wind.
perfectly capturing the radiant energy inside a dome-shaped form that minimizes any surface exposure. It's just brilliant.
When you compare these two extremes side by side, it's pretty fascinating. In the jungle canopy, you have an open, highly elevated form built to catch breezes and escape the trapped ground heat. Then, out on the polar ice, you have a dense, compacted skin of snow designed to trap heat inside and block out freezing radiation. The underlying rules of physics, exactly the same in both places. But because the climates are total opposites, the architectural response absolutely must be opposite. Basically, climate dictates design.
So look around you today at the buildings you live and work in. How do their form and skin actually respond to your local climate? Or are you living in a glass box in the middle of a desert? As we look toward a more sustainable, resource-efficient future, it turns out that the best way forward might just be looking back at these ancient masters. You simply cannot out-engineer the climate, you have to design with it. Thanks so much for watching The Explainer, and we'll see you next time.